Okay, let's solve another problem on a probability theory. So, hackerrank task number 2, called of the gift. Isaac has to buy a new hacker phone for his girlfriend. He is exploring the shops in the town to compare the prices, and he finds a shop located on the first floor of a building that has a unique pricing policy. There are n steps leading to the shop. A number ball is placed on each of the steps. The shopkeeper gives Isaac a fair coin and asks him to toss the coin before climbing each step. If the result of the toss is head, Isaac should pick up the ball. Otherwise, he must leave it and proceed to the next step. The shopkeeper then asks Isaac to find the sum of all the numbers he has picked up, let's say S. The price of the hacker phone is then the expected value of S. Help Isaac find the price of the hacker phone. Okay. Input format. The first line of the input contains an integer and the number of steps, and lines for which are the numbers written on the ball on each step. Output format, a single line containing expected value. Okay. So we can have some stairs, and from 1 to n stairs, and on every stair we toss a coin, and if we have head, when the take some number from this stair, and we do this on every stair. So okay, how we can solve this? I think here we can take all possible subsets. If we look all the set of all stairs, these numbers, set of all these numbers, and they take all the possible subsets. Each of these subset represent some outcome, and all these outcomes has the same probability because we throw the toss coin. Okay, so how can we find the expected value? We can just take all these subsets, transforms each subset into some sum. After this, we can summarize all these sums and divide them by the 2 number or to the power of n. This 2 power of n represent the total number of subsets or outcomes. Okay, so I think at first we need a function which generate to us all possible subsets. I think that here we have this solve function prepared to us, and it has no type signature, and this is bad. Let's add type signature to it. I think it has a list of int type signature. and we want to produce a double. Also our expected value. So. Okay. So we can start. So I think at the end I need the list of a list of sums, and I want to summarize them. Okay. So we need to summarize the list of sums. I don't know this list at this moment, but I will define it. And the final expected value, we need to take all this sum and divide it to the. We need to divide on 2 power of n. Okay. After this, we need to define our L sums. We need to define n, which is can be defined as the length of balls. Now we defined L sums. So here for this we need all subsets. And the type of this thing will be the list of lists. When they have this thing, we can summarize all this thing with, I think, something like fold L function, for which we need to provide the no. We need to use functor here. We can take all these subsets and provide some lambda function which takes some subset. Takes subset. Or the set just takes subset of the subset and summarize this subset. Okay. I think okay. Now we just need to implement the subsets. So we have list. Actually, we need our set, initial set, and we finish this set of sets. So set here represented as a list. Okay. But what is the L sum? Let's say something about our L sums. So L sums is the list of int, because actually each int represent here the sum of balls which we pick up. Okay. Now we need to have this subset function. How can they define? Let's define it for some corner cases, I think. If they have empty set, then they have this thing. So I think the empty set must be element of these possible subsets. If they have, and also here we need, I think, and better match our list with the element and the tail. And here we construct our solution from the, so we can solve some subtask. We just can say here that give me all subsets for T, and for this thing I will add some subsets with X. So here subsets without X, here subsets with X. This thing they have no problem. This is just a recursion. But this thing they need to define. And we define it here. Subset with X. How we get it? Well, we can take previous subset T, and they need to add an X element into every element of subset T. So they use functor. Let's apply some function which takes subsets and produce a new subset like this. Okay. I'm not sure how fast is this, but we can try. And here, of course, I forgot some argument for our subset function, the balls, initial balls argument. So this is the list of all our balls, all the stages. Okay, and I think we can try to first do a first run. Of course, I expect some errors, and I just want to see them to correct them. Okay, this is an error, and I didn't like the ambiguous situation that this length function. Let's try like this. Okay, next error. I have naming problems. That's okay, typos. Okay. Error with much expected type double with actual type int. Okay. We need to, I think, use from integral here function. From integral. So we need this to get correct types. Hit replace mod. What am I doing wrong here? Oh, let's try like this. Why I wrap it here? Don't need. I think I don't need this wrap. Okay. Wow. Simple test case is done. Okay. But what if I have all the cases? Very bad. Okay. Time limit exceeded. As I think the problem is that I use this subset function and it is not very fast. It's not tail recursive, and also we had this at the start. I found that it has this import here, the bits, and I think, wow, maybe it wants that I need to implement this subset of bits. So actually this is very easy, just loop +1 and we can and then every on every step these bits represent the some subset. But at first I want to try to optimize this thing. I want to make it tail recursive, and if this not help, I will try to use bits. So we need a new subset function. Much faster, I think. Okay, let's comment this for a moment. How I want to define this function. So I need additional argument here. Yes, I need additional argument. We will start from a list of int, which will represent our result. And also we, as a second argument here, have actually our set. And what we do. So this is the result. What they do, we take one element from this from the initial set, and the add it to our result. So we take our result has subsets without this element, but with all elements that we proceeds before. And we need to add this element to, so we need to add this element to all the subsets which we proceed before. This means that we need to have some r prime here with the added element, and our initial set is discrete. It has no x anymore, it goes here. But of course I need to define r prime, and r prime is defined as r plus. So we take x, and to every, we take r, and to every element of this r we add the x, like this, I think. Okay. So we very aggressively expand our r with r prime, and it's double on every iteration. Okay. And of course we need to remove this thing, because they have some error and we have no any more elements to add. We need to return our error, our result as it is. And we need to provide this additional argument. We can avoid the helper function, but I don't want to write additional wrapper. So let's try like this. We start from the empty case and want to find all these solutions for all balls subsets. Let's try to run this. Okay. And of course, this is our result. This is our temporary result, which in the end step has the correct decision. So I need the entire brackets here. Okay. Honestly, I'm not sure that this is fast enough, because I don't like this plus plus here. But let's try. Yeah. Wow. Runtime error. Runtime error. No, I don't want to Pay my hackers. Oh, I think the problem is that, yeah, as I said, that this plus, we need much memory for this thing, so that's why it can rush like this. So I need to find something to optimize this. Okay, I realize the problem. The problem is that, yes, it is too hard to generate for memory, too hard for memory to generate 2 power 40 different subsets. And actually we didn't need this. We can write some simple recursive function which takes initial subset. I think they can represent it as a bit, some list of bit, and we take the corresponding sum for this bit, accumulate it on this step, and go to the next step for the next subset, just simply by increasing the bit, and accumulate a new subset into our accumulator. And we just finish then our bit is increased to the limit of 2 power of n, and they will have this sum. Okay. So this means that they need to look more precisely into this data.bits module. And finally, I find that this task is tricky task. Okay. I implement the tail recursive subsets and find that terminated do a timeout again. After this, I start to think how to optimize this. And I go to this solution. So I start to think, why I'm generating these subsets? Maybe I can just summarize all the outcomes on every step. And really, I do this with iteration function, So we start with a 0 step, and on every iteration, increase it by 1, go until our final outcome 2 power n. By the way, we zooming our outcomes. So I even optimize the sum function with this folder function, and found that it has no time termination, do a timeout. And after this, I add vector. I think that may be at least too big, but what elements? It's not big. But I think okay, I will add vector, and add vector, and it doesn't, and it doesn't accept this. And finally, I started to think that maybe I'm doing something wrong, and really I do something wrong. Okay, I count this as simple sum, and what is this sum? Do they need to do this 2 power of n iterations? If we look carefully into this sum, we can find that every ball, if we pick up some random ball, and how many times is added into this total sum. So we have half of the situations when we pick up this ball, half of the outcomes when we pick up this ball, and half of the outcomes when we don't pick up this ball. So this means that we can just take the number of this ball and multiply it on 2 power of n minus 1. And to do this for every ball, we will find our sum. Okay. So this means that I need to comment this LSUM and define it in a more clever way. Okay. So we take LSUMs and defined it as an integer, but now we have another logic. So I think they need a range from 0 to n, from 1 to n. So we have our n stairs, and we take our n and take our stair, and what we do, we must take this 2 power of n minus 1 and multiply it to our balls. We didn't need to optimize this list. With I position. And we need to summarize all this. We summarize all these, and okay, this this is solution. Let's try. Okay. So types. So I think they need from integral. So here and take from integral. Index too large. Cause the indexing from 0 to n minus 1. Okay, let's try to submit. And waiting. Oh, and we have problem again, and I think the problem is in formatting, so we need to output it in this format. But do this. So actually this code was already here, and I don't know do it formatting or not. Oh. Just show the result. Okay, I think it was not good to use just show the result. They need to add formatting here. So we need to import some function printf. Import text printf. This function. And after this, so we need to format our string with this function printf, and like this. We need only one number after the dot. Okay. So I fix it like this and get errors again. Okay. Okay, I found the problem. As always, it was very stupid. So I think it was an overflow problem, because at first I put this from integral here, and these numbers are very big, and that's why we get overflow. So at first they need to transfer our type into the integer type for the balls, and this will save us from overflowing. Okay, so this is final solution. It's very small, and I do a lot of unneeded work, because at first I didn't see this optimization in the logic of this solution. Hey guys, thank you for watching. Push like, push subscribe, and bye bye.